Hello and welcome to Algebra 2, Chapter 7.2, some extra examples. Alright, so we're going to start out with simplifying basic things with exponents. So for the first example, remember if we are multiplying and we have the same base, what do we do to the exponents? We add them. So remember you keep your base, so we're keeping 3, and we're going to add 1/4 plus 3/4, which is 1, and so your answer then is just 3. The second one, there's two ways you can do it. The first way is you could just go ahead, if you have an exponent to an exponent, you multiply, and so this becomes 64 to the 2/3 times 8 to the 2/3, and then if you want to simplify those, that would be the cube root of 64 squared and the cube root of 8 squared. So the cube root of 64 is 4. So this is 4 squared times the cube root of 8 is 2 squared. So you're going to get 16, not 8. 16 times 4, which is 64. Now the other way you could do it is because they both have the same exponent, you could go ahead and pull the exponent out, and like that, and then you're going to have 64 times 8 would be 512 to the 2/3 power, and really you could just do that in your calculator and you get 64. Okay. This property we used right here comes from if you have a times b to the mth power, that's a to the m, b to the m. So we're just doing that property backwards. Okay, so the same thing for the last one, however you want to do it, but if we go ahead and just multiply exponents, you're going to have 3 to the negative first times 6 to the negative first, which is 1 over 3 times 6 because they both go to the bottom, and we're looking at 1/18. Okay, so again, if you are dividing, what do you do with your exponents? We subtract, and so 1 minus 1/2 is 1/2, so you get 4 to the 1/2 power, which is the same thing as the square root of 4, which is 2. So go ahead and take it all the way down to 2. All right, and this next one, we're looking at 54 to the 1/2 power over 27 to the 1/2 power, because an exponent to an exponent you multiply. And because they have that same power, you can go ahead and divide. So 54 divided by 27 is 2, so you get 2 to the 1/2 power, and you can just leave it like that or make it the square root of 2. So that property is your a over b to the m equals a to the m over b to the m. So because they both have the same exponent, really what we did is we looked at it then like that. So there's several ways you can look at these and several methods you can do to simplify them. Okay, so if we have the same index, we can go ahead and multiply them. That's our product property. So 27 times 3 is 81, so this is going to be the 4th root of 81. And then we're going to need to see if that simplifies. And so what we want is we want a perfect 4th root to go. Actually, let's try the 4th root of 81, and the 4th root of 81 is 3. So there we go. All right, and the next one, again, because they have that same index, we can go ahead and divide them. So we're going to get the cube root of 125. Cube root of 125 is 5. Very nice. Okay, so 6 times 3 to the 2/3 plus 4 times 3 to the 2/3. Okay, so if I have 6 of these, I'm going to add 4 of these, then I'm going to end up with 10 of them. Doesn't matter what them are, you get 10 of them. And the next one, remember, you have to have the same radicand if you're going to add or subtract. So if we split this up, I know 125 has a perfect cube root, and I know that 125 times 5 is 625. So this is 3 cube root of 5 minus 1 cube root of 5 makes 2 cube root of 5, except I did that wrong, didn't I? Cube root of 125 is, how about 5? So sorry. How about 5 and not 3? So 4. There we go. Okay, so simplifying, assuming all variables are positive, I would use your quotient property to split it apart. So you'd have the 5th root of x to the 5th on top and the 5th root of y to the 10th on the bottom. On top, the 5th root and the 5th power cancel, leaving you with just an x. And then on the bottom, that separates into the 5th root of y to the 5th and the 5th root of y to the 5th. So there's 2 of those. They both become y, so you get y squared. So x over y squared. Now, the other way to look at that is if you have y to the 10th, remember that your index comes around. So you get to the 1/5 power, which would be like 10 over 5, which is 2. So x over y squared there. Okay, so what about this next one? We got all sorts of stuff going on. You really need to look at one base at a time. So if we look at the numbers, 8 divided by 6, 18 divided by 6, is 3. So we get a 3, it's on top. Then if we look at the r's, and we are subtracting, so we get 1 minus a 4th is 3/4. So we're going to do r to the 3/4 on top. The only place we have an s is on top, so you get s to the 2/3 on top. And the only place we have a t is on the bottom, but it's negative, so it needs to come to the top. There is your answer. So remember, don't try to bite it all at once. Take one little bite at a time. Okay, cube root of 8r cubed, s to the 5th, t to the 10th. So first of all, the cube root of 8 is 2. Cube root of r cubed, that's 1r, so that's going to come out. So another way I like to think about these is every time you have a group of 3, it comes out as a group of 1. So if I look here, how many groups of 3 s's do I have? I have one group of 3 s's, and I have 2 s's left. And then if you look at your t's, how many groups of 3 t's do I have? I have 3 groups of 3 t's, and I would have 1 left then, because the 3 groups would make 9, 1 more to make 10. So just another way to think about it, still works. Okay, 4th root of 625 is a way to think about this one here. 4th root of 625 is 5. J to the 2nd, because you're taking 8 times a 4th. K to the 1st. That's all we're doing. Exponent to an exponent, you multiply. Okay, so let's simplify this. 4th root of x to the 8th is going to be x squared. Okay. 4th root of y to the 11th is going to be y squared 4th root of y cubed. Okay, because 8 of them came out into this squared right here because it was 2 groups of 4. And then you would have 3 left over to stay inside. So those are your 3 you had left over. Now on the bottom, we're going to have one group of 4 that's going to come out. So there's my one group of 4. And then we have 2 left that are going to stay inside. Okay, now you cannot have a 4th root on the bottom. And so we are going to need to rationalize, and we're going to rationalize by the fourth root of z squared, because that's going to make a z to the fourth. So if this is a z to the fourth, that's going to come out as 1z, leaving us a z squared on the bottom. And then on the top, we're going to have x squared, y squared, fourth root of y cubed, z squared. Just multiply that together on top. Okay, 15d squared e to the 2/3 f all over 5d f to the negative fourth. Again, one bite at a time, you're going to look at your numbers. 15 divided by 5, that is 3. You are dividing. D squared over d. That is going to be just 1d because you're going to subtract. E, we only have that one e to the 2/3 stays on top. And then f, you're subtracting, and that is 1 minus a negative 4. Be really careful on those minus and negatives. So we get f to the 5th. Okay, simplifying still. If we have 6 square roots of s, and we subtract 2 square roots of s, and we add another square root of s, we are left with 5 square roots of s. Okay, so 6 minus 2 is 4, add another one is 5. If we have 4m squared into the 1/3, and we subtract 6m squared into the 1/3, we are left with negative 2m squared into the 1/3. All right, and our last one here, notice your radicands are not the same, but I can pull out 2 groups of 3 here, so we're going to have 3y squared. There's my 2 groups of 3. Cube root of 6y, there's only one y left. 2y squared, cube root of 6y. Now they have the same radicand and even those same y squareds out front, and so if I add them together, I get 5y squared. Cube root of 6y. All right, into some word problems. The weight W in tons of a whale as a function of length in feet can be approximated by the mode, or model probably. W equals 0.1077 L to the 3/2 power. Approximate the weight of a humpback whale with length 49.17 feet. Okay, well, if it's giving us the length and we're looking for the weight, all we're going to do is put that in, and then I would just use my trusty calculator and crunch that number. Make sure to put parentheses or multiplication or something to make sure you follow your order of operations. And I get 37.13, and this is weight in tons, so it is going to be tons. And one last word problem here. A pilot whale is about 1/5 the length of a blue whale. Is its weight also 1/5 the weight of a blue whale? So if you look at this, you know, we had our equation, W equals 0.1077 L to the 3/2. So if my length becomes 1/5 the length, right? What really did I just multiply this side by? Because this is going to be 1/5 to the 3/2 times L to the 3/2. And so if we look at 1/5 to the 3/2, I'm just going to do it in my calculator to get a rough estimate. This is 0.8944. And so this right here multiplied the right-hand side by 0.089. You would have to do the same to the other side. That does not equal 1/5. So no, it would be 1/5 to the 3/2 the weight of the blue whale. All right, so there's your extra examples. Let me know if you have any questions. We'll see you in class.